does the Pythagorean theorem relate the side lengths of a right triangle? Think about this question during the lesson. Triangle ABC is a right triangle with side lengths A, B, and C. The legs A and B are the shorter sides of the right triangle. The hypotenuse, C, is the longest side of the right triangle. Construct a logical argument to show that A2 plus B2 equals C2. When you think logically and use definitions, properties, and given facts to construct an argument, you are developing a mathematical proof. What is the area of the triangle?
Select your answer.
The area of the triangle is 1/2 its base, B, times its height, A. Let's begin by composing a square using 4 copies of the right triangle. The next step is to rearrange the triangles inside the same square. The total area of each square is equal to the sum of its parts. So the total area of the first large square is equal to 4 times the area of each right triangle, or 4 times the quantity 1/2 times A times B, plus the area of the square in the center, which is C squared. The total area of the second large square is equal to the sum of the area of each of its parts, or AB plus AB, plus A squared plus B squared. Because both large squares are exactly the same size, the areas are equal. Solve the equation by multiplying 4 and 1/2 on the left and combining like terms on the right. Apply the subtraction property of equality to cancel 2AB from each side of the equation. We've shown that if triangle ABC is a right triangle, then A squared plus B squared is equal to C squared. A logical mathematical argument in which every statement of fact is supported by a reason is called a proof. What you just saw is one proof of the Pythagorean theorem. There are many other ways to prove this theorem. Now you know how the side lengths of a right triangle are related. A right triangle has side lengths 15 centimeters, 25 centimeters, and 20 centimeters. How can you use the Pythagorean theorem to write an equation that describes how the side lengths are related?
Okay, so we have a right triangle. Then let's draw the right triangle. This is just for visual. So we have our right triangle, and it says side lengths are 15, 25, and 20. So we're going to use the Pythagorean theorem to write an equation. So we simply just put the side lengths. So the side lengths would be this side and this side. So we're going to take 15, put it here for A, and then for B we'll use the hold on. So if I put 25 here, 25 as B, 15 squared is 15 times 15, which is 225. And then if I do 25 times 25, that'll give me 625. And then my last number was 20. And 20 squared would give me 400. 20 times 20 is 400. Well, I can see 225 plus 625 is not going to equal 400. So that means the order of my numbers is not correct. So instead of using 25 here and 20 there, I'm going to switch those two and see if that changes. So I'm going to put 20 and then 25 here. So 20 was 400 and 25 was 625. So now if I do 225 plus 400, that does give me 625, which is equal to 625. So that is the correct order in which to put the numbers and proves that this theorem is true.
What is the length of the hypotenuse of the right triangle?
Use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse. So here's a leg, there's a leg. The hypotenuse is here. So we have a squared plus b squared equals c squared. And our a is 5, our b is 12. And then we solve or calculate that. We get 25 and 144. Add that together, you get 169. So our hypotenuse is 169. But we want to know what c is without it being squared. So you find the square root of 169, which is 13. So c is equal to 13 centimeters for the hypotenuse.
Mara is repairing the trim on one side of a display case sketched at the right. She has a piece of trim that is 14 inches long. Does Mara have enough trim to repair the display case?
All right, so I'm going to select the sides. Okay, not of that one, of this one. So B, Mara needs to know whether a 20-inch piece of trim is long enough. The hypotenuse of the display case is 25 inches. And this leg of the right triangle is 20 inches. So here's the equation, 20 squared plus b squared equals c squared. So that c is going to eventually be substituted with that 25 like they did here. And then you solve. So that's 400, that's 625. This is exactly like that. Try it we did in example 1 actually for this portion. And then you have, to solve for b, you have to move the 400 over to the other side of the equation by doing the inverse. So they subtracted 400 from both sides. So now we have b squared is equal to 225. And then we want to know the singular answer for b, not b squared. So we find the square of 225 by finding the square root. And b is equal to 15. So she needs 15-inch piece. So she does not have enough to repair her display case because she only has 14 inches.
A right triangle has a hypotenuse length of 21 meters. It has one leg with a length of 15 meters. What is the length of the other leg? Express your answer as a square root.
So again, I like to draw. So if I draw, right, now it says it has a hypotenuse. We know our hypotenuse is here. That length is 21. And then one of the legs is 15. So here would be a leg 15. What is the length of the other leg? So that's the leg we don't know. And I'm just going to make that a B. So what is the length of the other leg? So first, let's write out our equation, a squared plus b squared equals c squared. So we know c squared is equal to 21. I'm sorry, c is 21, so 21 squared, and then we don't know b squared, and then a is 15 squared. All right, now we need to solve. So 15 squared, 15 times 15 is 225, plus b squared is equal to 441. And so because I need to find the value of b, I need to subtract 225 from both sides of my equation to get the value of b squared. So 441 minus 225 is 216. I'm going to write it over here. So we have b squared is equal to 216. Then I need to find just the value of b. So I'm going to find the square root of 216. But I just realized it says we need to find the answer to the square root. So we don't have to find what that equals. So we are done.